Hello, my name is Jerry Elter, Assistant Managing Editor for ASHRAE Journal. Thank you for joining us for today's webinar, part of the ASHRAE Journal Supplier Webinar Series. The series provides information to high-performing buildings readers and to others about products and technology of interest to industry professionals. ASHRAE does not review supplier webinar presentations. The following presentation has been prepared by Carrier. The subject is Healthy Building Control Strategies. Today's speaker is Brian LeDuc. Brian is the System Applications Product Manager for Carrier Commercial Controls. He has been with the company for over 35 years and has held roles in project engineering, project management, and technical support. Brian resides in Albuquerque, New Mexico. Brian, the microphone is all yours.
Thank you kindly, Jerry, and on behalf of Carrier, I'd like to welcome everybody to our presentation. As Jerry indicated, we'll be talking to you a bit about healthy building control strategies. Learning objectives here, we want to share with you ways that you can take advantage of the capabilities of a modern building automation system to improve a building's overall indoor environmental quality, and why certain pandemic-related control strategies can remain in place or possibly be adjusted to achieve healthy building benefits in a post-pandemic environment. Target audience, HVAC consulting and specifying engineers, HVAC designers, controls engineers and technicians, controls sales staff, building owners, facilities managers and staff, anyone else that might be interested in the critical role that a building automation system can play in meeting the requirements of a modern, healthy building. This program, Carrier is authorized to offer 0.1 CEUs for this program. You must be present the entire time. To obtain credits after the presentation, send an email to training@carrier.com. Put in the subject line Carrier Healthy Buildings presentation, and you'll get an email back with a link to take the online knowledge check and then access your certificate. A little bit of a change in lineup here. Caprice is not going to be joining us today. In her place will be Laura Molesworth. Laura is marketing manager for Carrier Commercial Controls. Obviously, I'm Brian LeDuc. Welcome. And also joining us today is Dominic Iorio. Dominic is the sales team lead for the Carrier Commercial Controls Group. Dominic will be assisting me with Q&A. Laura is going to manage the Q&A at the end of the presentation. Dom will assist me with answering whatever questions you guys might have for us. Okay, with that said, let's dive in. Healthy building control strategies. The suggestions we're going to discuss here should be achievable with most contemporary building automation systems. For the purposes of this presentation, it's assumed that such systems will consist of a network of communicating direct digital HVAC controllers, various sensors, network communication devices, and a web server-based user interface. Due to the variances in the capabilities of such systems, the suggestions and recommendations here are by necessity general in nature. The specific steps required for implementation, as well as the possible need for additional controllers, sensors, and field programming, that will vary with the systems in place. It should also be noted that any mechanical additions or modifications that may be required to implement any of these recommendations are outside of the scope of the presentation. Lastly, and perhaps most importantly, it's strongly recommended that the controls and equipment are operating as designed and, if necessary, recommissioned prior to implementing any of the suggestions contained within this presentation. What is a healthy building? A healthy building provides an indoor environment that is optimized to positively impact the health, well-being, and productivity of the occupants. To achieve this, Buildings must strive to meet a number of foundational criteria that cover everything from ventilation and air quality to lighting, views, physical security. Part of a layered approach, creating a healthy building through engineering controls in spaces is a key component of combating COVID-19. So the takeaway here is that the engineering controls that many of us have been deploying for the last, say, 15 months as a response to COVID have laid down a solid foundation for an overall healthy building control strategy. So let's talk engineering controls during the pandemic, and that'll set the table for our transition to healthy buildings. So during the pandemic, guidance that has been available called for the implementation of steps to help mitigate the potential spread of infectious disease. That encompassed recommissioning all the systems and controls, as I mentioned earlier, increase outside air ventilation, improve the effectiveness of filtration, consider adding air cleaning equipment, maintaining humidity targets at levels known to limit infectious disease transmission, adjust systems for reduced occupancy in cases where buildings may have remained occupied but only partially, and then implement pre- or post-occupancy fresh air purge modes. These steps, along with additional controls that we're all familiar with, masks, social distancing, hand washing, et cetera, were critical to building owners and managers whose buildings remained open during the pandemic or sought to reopen after prolonged shutdowns. Takeaway here on this slide is no single strategy alone can assure healthy and safe indoor environment. Syracuse University has done some research that showed that the right mix of building strategies can reduce the risk of airborne transmission of pathogens up to 80%. That can include managed occupancy, air purification, devices, in-room air cleaners, an increase in fresh air if feasible, and ensure that the building is commissioned and operating per specifications. There is a link here to that study. This presentation will be made available after the session, so I'd encourage you to take a look at the study if you're interested in learning a little bit more. So hopefully we're now in a post-pandemic scenario. So let's talk a little bit about post-pandemic engineering controls. Okay. Right off the top, the takeaway here is that these recommendations have a lot in common with the pandemic focus strategies that we just talked about, but there will be some key differentiators. So continue the steps that did help mitigate the potential spread of infectious disease, apply recommended strategies for improved ventilation, air filtration, cleaning, and humidity control, monitor and maintain occupant conditions, which studies have shown can deliver cognitive, health, and other benefits to occupants and building owners. Reintroduce energy-saving control strategies that may have been disabled or dialed back during the pandemic. And also, you can benefit from improving on occupant awareness, to increase confidence that the environment that they're currently working in is safe and healthy. So again, some commonality there from where we were during the pandemic. So how and why do we benefit from a continued focus on engineering controls? First of all, we spend 90% of our time indoors. We can use healthy building environments to provide certain benefits. Improvement in cognitive function in enhanced green buildings, crisis response scores, information usage scores, strategy scores, all have shown marked increases in performance, improved personal health, again in high-performing green certified buildings versus non-certified buildings. Sick buildings symptoms have been 30% fewer. Sleep quality improved by 6.4%. And then lastly, there are improvements in societal health, energy reduction, and combined health and climate benefits up to one study has shown $13.3 billion. In addition, there are benefits in terms of climate change, CO2, and then reductions in air pollution in general, can result in fewer deaths, hospital visits, etc. The references here on the bottom are to the cognitive effect study, which was done at Harvard University. I would again recommend that if you're interested in learning more about this, that you take a look at the study. The address is just the COGFX study, COGFX. Study.com, and again, you'll have this presentation, which will have the links in it when we conclude. So let's talk about specific strategies. That's the core of the presentation here. So indoor air quality. So ventilation control, what problem are we trying to solve? Well, maintaining correct amounts of outside air can contribute to improved cognitive function, but as has been shown in other studies, can also help reduce the spread of infectious diseases. So in terms of how would you achieve that in a DDC-based system with rooftops, air handlers, air terminals, airflow monitoring. You can implement standard ventilation controls or enhanced ventilation controls if you have a situation where you do need to increase the amount of outside air above the design specification. That brings up the question, what is the correct amount of outside air? Current guidance suggests that systems with enhanced filtration and or air cleaning can, in most cases, be set to design levels of outside air. Okay? So there's probably no need to increase the amount of outside air in systems with enhanced filtration and or air cleaning. Systems that will require increased amounts of outside air beyond design levels, either for pandemic-related reasons or COGFX improvements that can be, those sequences can be deployed to maximize the amount of outside air consistent with the capacity of the air handler or rooftop unit. The ASHRAE Building Readiness Guide that has been continuously updated since I think last March, perhaps, does have some guidance on possible sequences to allow the input of more outside air, but taking into account that the capacity of the equipment may not be suitable to say go to 100% outside air. That's likely not going to be possible in equipment that wasn't designed for it. So the ASHRAE Building Readiness Guide is a good source of reference if you do have a requirement to increase ventilation, but take into account the capacity of the unit. And of course, in doing so, there also will potentially be an energy penalty, so you want to be careful about that. And again, the COG effect study that I referenced before cites the benefits of increased ventilation from a cognitive standpoint. Okay. CO2 monitoring and DCV control. DCV is demand control ventilation. So what we're looking at here is monitoring CO2 levels to ensure recommended ventilation rates. We have the ability to restore the energy-saving benefits of demand control ventilation. During the pandemic, guidance had recommended that CO2-based demand control ventilation be disabled. And the reason for that is that when you bring a building into occupancy and people begin to enter the space, it does take some time for the CO2 level to build up. And because demand control ventilation typically is designed to reduce the amount of outside air ventilation when a building is sparsely or not occupied, you could have a period of time when occupants arrive where you're underventilated as reference to design standards. So when we talk about enhanced demand control ventilation, it should take into account the amount of time it takes for a space to reach equilibrium with the amount of CO2 that is being produced by the occupants. So kind of a long-winded discussion, but the key here is, again, you can apply this typically in a digitally controlled rooftop or air handler, air terminals. You may consider airflow monitoring, CO2 sensors, which are typically required, but again, post-pandemic, you can still operate DCV, but you probably want to take a look at how it's enabled and consider enhancing the sequence so that it does not allow for a significant amount of time when occupants are in the space when we're underventilated. Pre or post-occupancy purge, the guidance for this has evolved a bit since the beginning of the pandemic. The idea there, the problem we're solving, is to purge a space of contaminants prior to or after occupancy to remove VOCs or TVOCs. Those are volatile organic compounds. TVOCs is total volatile organic compounds. CO2 and other contaminants. The guidance available today calls for either a pre or post occupancy purge, so you don't necessarily have to purge both after and before occupancy. Again, the logic in most DDC-based air handler or RTU controls typically will support purge modes. The implementation, again, pre or post occupancy purge, you don't need to do both. In addition, there are some sequences that do what we call a free cooling, pre-cooling scenario. If atmospheric conditions are suitable, you can do basically a pre-cooling scenario where you're bringing in outside air before you engage the mechanical cooling equipment. The benefit of that is if you're able to do so, it can take the place of a dedicated purge mode. Okay? The purge duration can be fixed, can be based on up to 3 air changes per hour, or it can be calculated. May 2021 ASHRAE Journal had a new article with updated basic guidance that talks about purge modes. And then also, again, the building readiness guide that I mentioned earlier also has a tremendous amount of information regarding setting up purge modes, air changes, and how it can be calculated. Filtration monitoring and notification, both during the pandemic and from a healthy building standpoint. Improvements in filtration have been recommended. I think currently, if the equipment will support it, up to a MERV 13 filter is recommended. You don't really have anything to control specifically in terms of the filters, but filter monitoring can be enhanced if you're increasing the effectiveness of the filter, and that can be accomplished with differential pressure sensors, again, DDC-based air sources. So if not already present, you can install either analog or discrete differential pressure sensors. Analog sensors would give you enhanced data so that you can trend and graph the performance of the filter over time. You can configure alarms to notify the building owner when you're approaching the point where we would need to change the filters. Again, these are all components of a typical BAS system, so the trending and alarming is probably boilerplate stuff, depending on the vendor in question. But the data could also be put into spreadsheets and graphed, etc. So simply making sure that you have filter monitoring can provide some very important data from the building manager's point of view and maintenance point of view. Portable air cleaners. These are have been recommended again during the pandemic. There are scenarios, particularly in schools, where it may not be possible to increase the amount of outside air being brought into the classroom. So portable air cleaning equipment can be deployed, which provide enhanced filtration. As a standalone device, they work perfectly well, but from a building automation system device, it would be beneficial to be able to monitor and control this equipment. So, again, we're talking a portable, if you will, air scrubber purifier, then adding a field installed programmable controller, which should easily be available in most BAS systems. And then you can add optional sensing if it doesn't already come equipped for CO2, occupancy detection, again, VOCs, TVOCs, temperature, humidity, differential pressure across the filters. So any or all of those things can provide a tremendous amount of data for the conditions in such a space. One of the big benefits that can be achieved is simply programmable start and stop. Again, if you're deploying these in a school, you could rely on the teacher, if you will, to turn it on in the morning, turn it off when they leave. But they tend to be pretty busy. So if you can automate that to ensure that the equipment is turned off when not needed, there could be some potential energy savings there. So again, remote monitoring, programmable start-stop, fan speed selection on certain units, the equipment status, sensor status, and then, as mentioned previously, in terms of alarms and trends, a building automation system should provide the capability to harvest that data and present it in a usable fashion for the building managers, building engineers. RH monitoring and control, the current guidance, and again, this was referenced in the May 2021 ASHRAE Journal article on reducing airborne infectious aerosol exposure, typically 30 to 60%, which happens to be the target range for comfort in most scenarios. But some additional studies have shown that humidity within that range also can help reduce the likelihood of viral transmission. So again, you have a healthy building scenario there, but also a scenario that can help limit the spread of infectious diseases. So how would that be achieved? Well, your air source would have to have either humidifier and or dehumidification controls. Not every facility would have that, but would have both, I guess I should say, but relative humidity sensors from a control standpoint, and then optional space temperature sensors. So if it didn't already exist, adding RH sensing to the air source and zone controllers to monitor and then maintain proper space RH. That's really pretty much BAS 101, if you will, but again, it has both healthy buildings and pandemic-related benefits that can be accrued. VOC, TVOC monitoring and notification. So what we're looking at here is leveraging your BAS system to add enhanced monitoring of indoor air quality while providing improved occupancy or occupant awareness, temperature, CO2, relative humidity, VOCs, TVOCs, particulates, all of these contribute to overall building health, and maintaining these values at comfortable and safe levels and keeping building management occupants informed can be useful tools to drive confidence that the building is being well maintained at a healthy and safe level. So again, this is a combination of controllers, either existing or additional controllers added to the system, field installed, various types of sensing, VOCs, TVOCs, particulates, CO2, et cetera. And then the wall or desk-mounted graphical displays, which are pretty common in most BAS systems, so you could easily provide a local display so that the occupants can see what the conditions currently are. And again, just to repeat myself, as a BAS system, once you are bringing in data into the system now, that affords you the opportunity for trending, alarming, et cetera. So it's the idea is to make sure that the occupants are informed. building managers are informed, but also depending on the contaminant in question, it can also be used to drive mitigation strategies, depending again on what you're measuring. So, it can be used to inform, it can be used to mitigate. Indoor, or excuse me, not indoor, but IAQ door and window monitoring. The problem we're solving is to make sure that doors and windows, which may be open or closed, do not negatively impact ventilation strategies. So monitoring of the conditions can be used to drive changes to your ventilation strategy. This can be done obviously with DDC controllers and field installed sensors, but most automation systems are also able to provide integration with other building systems such as security or access control. So if those are available on a given customer site and they support integration, then you can achieve these kind of monitoring scenarios without having to add hardwired sensors. Okay, early in the pandemic, there were reports circulated that certain older buildings, I think in New York, certain schools that lacked proper mechanical ventilation, they were actually encouraged to open their windows and use box fans and whatnot to improve on ventilation. Monitoring in such situations can be useful. From a verification rather than a control standpoint. However, systems that can provide mechanical ventilation for those systems, doors and window switches can be used as an energy-saving measure via modification to the existing strategy. And again, the idea here is to take advantage of the data that the system provides, and again, alarms, trends, reports, et cetera. And then, again, the big benefit potentially is ventilation sequences based on status of doors or windows. Okay, moving on to system operation and FDD, which is fault detection and diagnostics. We'll touch on some of these areas. Network health monitor. This is admittedly only indirectly related to overall healthy building performance, but it is critical that the BAS system network remain fully operational and free of any impairment that could impact the underlying control sequences in healthy building strategies. So the idea here is to provide monitoring of the network and the components of the BAS system to ensure maximum system performance. This will provide building operators with actionable network performance data, making sure that uptime is maximized. So, this may or may not be a component of a given BAS system, but a network building automation system with a web server UI should be able to provide some of this type of data. So the solution here is to monitor and report server health, network communication health, and then probably most importantly is controller operational status and health. So if you've got components, you get air terminals, rooftops, air handlers that are providing enhanced ventilation, for example, and they go offline, it's possible they may not be working correctly. So a higher level server-based network health monitor can quickly alert building managers and engineers that there are problems that need to be addressed. Some of the BAS systems will have this built in. Others can provide a cloud-based solution to provide similar functionality. Fault detection and diagnostics. This is looking at your air terminals specifically, again, which are a key component in delivering ventilation, if you will. Initial and or continuous air terminal commissioning can help ensure optimal performance of both normal and enhanced ventilation strategies. Optimating, FDD, will allow immediate proactive response to pending equipment and or control issues. Kind of the takeaway here is that all healthy building control strategies are predicated upon the integrity of the mechanical and control systems, making sure they're competently designed, properly commissioned, fully maintained. Automating air terminal checkout and commissioning ensures that the air delivery equipment is always operating as designed. So again, a DDC-based air terminal control solution with a web server BAS system can automate sequences to identify and test the communications with the air terminals, verify that they're operating correctly mechanically, and also you can initiate, in some cases, a automatic commissioning sequence during unoccupied hours to minimize impact during the occupied day, but then delivering to the building manager, the building owner, a report in the morning to say, we correctly we identified a handful of air terminal issues, if you will, that should be addressed, or to provide verification that everything continues to operate properly. So an automatic commissioning solution can be a very powerful component of a healthy building strategy, simply by making sure that all of your air handling equipment, particularly the air terminals, your zone terminals, continue to operate correctly. Occupancy control and monitoring. This is a recommendation or a suggestion, if you will, to coordinate system operation with occupancy levels, sequence adjustments to improve or enhance ventilation based on real-time occupancy detection can have some benefits. Now, how you would achieve this, again, assuming a DDC-based control backbone, occupancy detection sensors, some thermostats have room sensing, occupancy sensing, electronic turnstile systems, sort of a people counting solution, or, again, looking at the potential for integration with access control systems could also provide the data. The takeaway here is having occupancy data available in real time can be a key driver to overall HVAC scheduling, set point control, and also driving enhanced ventilation strategies. So, occupancy-based control sequences, dynamic scheduling, diverting ventilation from unpopulated zones to occupied zones, and computing outside air intake based on historic, predicted, and or actual occupant levels. So there's a tremendous amount of benefit to a BAS system to have accurate occupancy numbers available in terms of outside air, ventilation, etc. Occupant awareness, we sort of touched on this a little bit when we talked about adding a zone or a system-level display indicating the value of some of the key building health, I should say, IAQ parameters. So we'll kind of expand on that a little more. This is, again, a zone display, an IAQ zone display. The key here is delivering enhanced occupant awareness and engagement, providing confidence that the facility is maintaining healthy building standards. So a zone-mounted display, DDC controller to bring the sensors in, and then a variety of possible sensors, basic temperature, humidity, CO2, VOC, TVOC, particulate matter, and then even potentially pathogen. Custom graphics and logic would be required to compute and display informative and actionable indoor environmental data. So the idea here is to inform not just the building managers, the building engineers, but also the occupants. Taking the zone level approach to the server level, if you will, again, very similar to what we were doing with the zone level display, but this is bringing it up a level, taking all of the building data and compiling it for a server level or possibly a cloud-based display. So again, network DDC controllers, IAQ sensors. Advanced analytics can deliver, healthy building indicators such as temperature, humidity, ventilation rates, all of the sensors that we've been talking on throughout the presentation. It can also monitor the energy impact of selected strategies, and it can be applied really anywhere from the local to the enterprise level. Next slide is really just a blow-up of that to let you see what such a storyboard could potentially look like. So you've got your temperature, airflow per person, overall composite healthy building score. I'll touch on that in a moment. Indoor air humidity, IAQ, CO2, if you will. All of that can be put into a custom dashboard that can really be accessed from anywhere at any time. Those displays are useful, particularly for occupants and building engineers that may have a technical background, but non-technical occupants may look at TVOC and CO2 and particulates and not really understand what that means. What's a good value? What's a bad value? So what could also provide benefit is to simply compute an index based on a number of those inputs and simply display that. Make that available to an occupant, say a non-technical user. Something like that, again, driven by DDC controllers, sensors, etc. But it could be pushed out to a local display device, a smartphone, a web server. The takeaway again is that for a non-technical user, looking at individual parameters of IAQ it probably may be overwhelming or difficult to understand, whereas everybody can look at an index that goes from 0 to 100% and have a really good idea of the overall health of the building. Now, these can be quite complex in terms of how they're calculated, weighting, things of that nature. But again, it can be in a BAS system that has the ability to put together, custom logic. It shouldn't be all that difficult to put together those programs to drive a single index, and it'd be very beneficial again particularly to a non-technical occupant or a building manager who just wants a quick check as to the overall health of their building. Going the other way, a building engineer might want much more granular data than a simple 0 to 100% value. So again, you can take all of this data and put it together at the building level, floor level, zone level. You can still compute a normalized index based on all those inputs, but you can provide an at-a-glance screen to a building manager, building engineer that will let them know quickly what the status is of all of the equipment in their building. So again, the idea is that a building engineer and a manager may want to see data that is much more granular than a simple index. So the capabilities of the BAS to crunch those numbers and graphically display it can provide that benefit without too much difficulty. And the analytics can be rolled up from, again, the zone level all the way up to the building level or even the enterprise level. It's really all a matter of just crunching the data. The mobile app solution, this is maybe not quite as easy to implement, but all of us pretty much have a mobile phone on our desk, in our pockets, permanently attached to our hands. Can we do something with those to leverage the fact that they're everywhere to help contribute to healthy buildings? The sky, or the cloud in this case, is really the limit. So what can you do with this? Again, harvesting all that data can be used to drive occupant engagement awareness, provide personalized occupant experiences, so allow a building occupant to have a contactless user interface for perhaps lighting, temperature control within their space. But it also could be used to drive sophisticated occupancy-based control strategies. So at the building or cloud level, you have the ability to integrate data from an HVAC system, access control, lighting control, fire life safety, room bookings, a full integration driven down to an iPhone app or an Android app can be a tremendously powerful tool in creating and managing a healthy building, and again, driving occupant awareness and engagement. These solutions can be tailored to the specific systems in place. Obviously, not every customer is going to have integrated access, lighting, fire life safety, HVAC. They may or may not have that, but you can dial in the capabilities to match whatever systems are there and whatever integration capabilities are available. These are typically available more to larger customers with large-scale facilities, but you can, again, use it to create occupancy-based control sequences. So when we talked a bit about people counting and such, you can use the presence of the phone to indicate when somebody is in the building, and that can be used to drive dynamic scheduling, again, diverting ventilation to occupied areas, adjusting the outside air intake, again, based on historic, predicted, and or actual occupant levels. So there's, again, the sky is the limit in terms of what you can do with a mobile app in terms of not just driving actual strategies, but driving occupant engagement and occupant awareness. And that's really the last detailed slide. So, wrapping up, a modern BAS system is a critical component in the effort to deliver on the promise of a healthy building. Many of the pandemic-focused strategies that we may have implementing over the last 15 months or so can remain in effect post-pandemic, possibly with some modifications. Strategies from simple to complex can be deployed to match the customer's exact requirements. The CogEffect study has shown that healthy building-focused engineering controls can deliver direct and indirect benefits to building occupants and owners. And then leveraging the data gathering capabilities of a modern BAS can drive increases in occupant confidence that the building environment is safe and healthy, and drive enhanced control strategies, data gathering, reporting, etc. I believe that is my last technical slide. As a reminder, this program provides to you an offer of a 0.1 CEU. You had to have been present the whole time, and to obtain credits, send a email to training@carrier.com. Just put Carrier Healthy Building Presentation in the subject line, and then we'll be sending you back an email with a link to take the online knowledge check and access your certificate. And with that, Laura, what do we got for Q&A?
Yes, okay, so we have quite a few questions, so let me go ahead and kick it off with the first one in the queue. So with outside air quality varying so often, how does one design a system that consistently provides acceptable indoor air quality?
Well, obviously the mechanical side of the equipment has to be suitable. Your design specifications call for a specific amount of outside air, per occupant. You have to be cognizant of your environment. There are some locations that probably have very poor outside air quality, in which case you may be limited to what you can bring in. But it's a holistic solution, if you will. The mechanical systems and the control systems have to work together. We've really learned a lot since the pandemic began in terms of what things to measure, and I think there's still a lot of research going on into that. Mitigation strategies have to be applied based on the contaminant in question. So there's probably not a single quick, short answer to that, other than it does require an overall engineering approach to, achieve on the results you're looking for. Possibly enhanced filtration, air cleaning, et cetera, in places where the outside air quality is not good. All of those things contribute.
All right, thank you. Next question. As far as contaminant detection goes, have there been advances made to specifically monitor COVID-related infections in airflow?
There is research and development going on in terms of pathogen detection. I am certainly not a subject matter expert on that, but I know that there are university-level research programs underway to come up with pathogen detections. Obviously, some of that might be similar to a breathalyzer, blow into a tube, but for the purposes of an HVAC control solution, something that can measure in the airstream would be much more beneficial. But again, I don't have any specific data to share with you other than I am aware that there is research going on into that area. And not just COVID, but pathogens in general.
Okay, thank you. Next question. What is Carrier's view of UV-C irradiation of air handlers and rooftops to address viruses such as COVID?
Well, we do offer some UV-C solutions for our rooftops. They have some retrofit packages available. At the present time, my understanding, again, I'm not a mechanical, I'm a controls guy. My understanding is the solutions they have available are specifically for coil disinfection. They aren't suitable for disinfecting or addressing contaminants on the fly. I know there was some research earlier on in the pandemic that I read that indicated that those systems, air handler mounted systems, have to be fairly robust, and they're very energy consuming, if you will. So I think what we as a company currently offer is strictly for rooftop, not rooftop, but coil disinfection. I can probably follow up and see if I can find a little more information on that. I know our custom air handler division could probably deploy anything you'd want in that realm, but that's what I can share with you at the moment.
Okay. Next question.